Good morning. Let's also make sure, yep, looks like sound is working, video is working, stream is up. And I wanted to tweet out this time this morning because yesterday I kind of forgot to like hit enter and tweet out the message that I was streaming. All right, so good morning. Come watch me as I stream myself learning Rust. And Rust the language, not Rust the game. Today I'm working on the Rust book. What am I working on? I already forgot from yesterday morning. CD projects mine learning Rust. We are chapter 6.2 matching with options. So chapter 6. Okay, so send that out there and to all the Slack communities that care about this thing. Good morning, Jesse. Welcome to the stream. All right. That's where I want to send it out. Oh man, Slack is so slow sometimes, it feels like. I normally pre-write these and then put them in so I can just go through and like hit return for each channel, but I got up too late this morning for that. So I'm just copying and pasting into these different channels. There we go. And we're done the marketing part. All right, so looks like yesterday we worked on we got up to chapter 6.2, and now we're about to do matching with option turbofish type. At least that's what I assume that's what that is. And Felix, I believe you last time had a really great idea, which was when we reach the end of chapter 6, let's rewrite the Fahrenheit to Celsius converter application, but using Enums instead of whatever I used when I first wrote that. Okay, so let's open up the book too and actually read chapter 6.2. (6.2) and something matching with option T. That's where we are. All right. So in the previous section, we wanted to get the inner T value out of the sum case when using option T. We can also handle option T using match as we did with coin enum. Instead of comparing coins, we'll compare the variance of option T, but the way that the match expression works remains the same. Good morning, Felix. Welcome to the stream. Or I guess like it's morning for me, at least so I feel good saying good morning. I know it's afternoon for you. Let's say we want to write a function that takes an option signed 33-bit number, and if there's a value inside, adds 1 to that value. If there isn't a value inside, the function should return the none value and not attempt to perform any operations. This function is very easy to write thanks to match, and will look like listing 6.5. Okay, so what do we have here? We have our function plus run. It takes in x, which is an option I32. It's going to return an option I32. We have match and no semicolon, so we're returning the whatever match returns. None is this. Sum is then sum I plus 1. So since this is taking in the full option, we're taking ownership of that. And then we're returning, we're giving ownership back. Is option stored in like the heap like that? Or is it destroying the option and creating a new one each time? They didn't really talk about like the memory management of enums, so I'm curious. Let 5 equals sum 5, so we set that. Let 6 equals plus 1, pass it this 5, and let none equals plus 1 none. Destroying the option and creating a new one. Okay, so interesting. That's interesting that it's like completely destroying it every time. I don't know if it actually changes how I think about enums, but it is, I guess, nice to know. Let none equals plus 1 none, right? Because if we pass in none, then it gets nothing. So this is how we can sort of change things inside of options, I believe. Because if it's some I, we don't care what the I is, but now we have this I here. Okay, matching sum T. And in fact, maybe before we go on, let's implement this. Let's come back to here. We'll go into chapter 6, option type, and we'll just open code here. Open it over here. Hey, it remembered where I was. Okay, so we previously had this coin, and we have the, let's see, what can we do? Can we use this and sort of like change things around? Like, for example, we're just saying like, hey, your type coin penny. I don't know if I can actually do that easily. Maybe I can do the value that we have totally. This is just for starters. There are ways to do it without destroying and reconstructions. Oh, because X as ref mutable and okay, so basically there are these other ways that we can do, but they're trying not to like confuse me or something, or like make it easier on me. That's awesome. Thank you, Felix, for that information. Okay, so I'm thinking if I create, I guess it's not really, if we come back to the book here, we're going to create an option oh, so we just call it sum, and that is an option. So like, because sum is sum returning, is that a function that returns, or is it because it's capitalized, it's doing something else? I'm still sort of unclear on sum, and I try to look through the documentation. I just looked, like, I didn't have the best example in my mind of what exactly it is. So if it returns a basically option enum, then that's cool. And it auto detects what type it's going to be based upon sort of looking through here when it compiles. So if I say something like in main, if I have sum is an enum variant, sum is a shorthand for option, sum, because option is too common, they made it shorthand. Okay. So it is just a full option that I'm getting when I do that. So if I do something like let total value equals sum of 0. So now I have 0, and I want to create that's going to add the value. So we get the coin value, which is going to get whatever it's worth. And then I want another function that's function add coin value. And so this is going to take in the value itself. So that's going to be what? I guess I could just say amount or cents, and that's going to be a U32. And then I'm going to have the sort of like total value. And that's where we say that this is going to be an option with this type. So it's option, and I want to make this signed because we could potentially have negative. So option I32. And I'm going to make this. This is going to return an option I32. And then I realize that I'm probably going to want, now I'm going to want to print out the value of this. Is there a, but because I'm not like defining it as this, am I going to be able to derive debug from it? I don't know, let's find out. Okay, so we're going to be able to get this option I32. We're gonna basically do the exact same thing that they did here. So we're going to say match the total value, and basically we're going to have none and then the sum. And so like if it's none, we're going to return none, and if it's sum, so none, we just return none. However, if it's sum and they're going to pass in whatever value it is, and I believe that this is just a variable, so I can name this like current cents, but current cents. I want to return sum of cents plus, but this is I32 and U32. Am I going to have converting problems here? I bet I am. I might want to make this U32 just to ensure that I don't run into like, oh, converting problems. Because we haven't like, I don't, have we learned, I think we've learned the different parse, right? We can parse it into this value. All right, I'm now curious about what error I'm going to get if I try it on my own without parsing it and then parse it to get the right value. So cents plus current cents, and that's it for this match. And then for each one of these, I have like a penny, a nickel, and a quarter. I can now it's like total value equals sum this. I have this, like my coin is worth this cents, but at this point in time, I can now add into that value. So we're gonna like just create a new variable, right? So yeah, let 6. You can use debug if the type you are wrapping is also debug. So option U32 implement, oh right, because I can debug a number. Sorry for using quote. Oh yeah, no, I know like YouTube chat is not that great. It definitely sort of like screws up some characters. But thank you for that information. Mismatch types. Expect I32 found U32. And I can't remember off the top of my head, was it just parse? I vaguely remember us parsing before. Okay, parse was not in there. I need to go find how to do that. I will go and do that in a second. Until then, I want to get this again. I'm going to shadow total value. So let total value equals, because it's destructing and like recreating, I don't need to like mute it. I'll just shadow it every single time. And yes, this would probably be better in a loop, but I'm not going to worry about that right now. I only have 3 of them. So let total value equals, and then I'm going to add coin value. Add coin value, we're going to add in get coin value of my penny, and then we're going to add in my penny. No, not my penny, total value. You can't add, yes, I know I can't add a U32 to an I32. I need to parse it, but that's not the right way to do it. I need to find the correct way to convert one to the other, and then I'll do that. Just makes sense as an I32. Well, if I change it there, I'm gonna need to come back and change it here. And then I don't need parse at all. That works. I mean, yeah. I also do want to find out how to properly convert an signed integer to an unsigned integer. And I can't remember if that was taught to us in chapter 3. So I know they went over a bunch of that kind of stuff. No, literally as mean cast, you can use sense at, oh really? So I read that completely wrong. Hold on, oh, that's too much. Okay, so I have, this is passing a U32. We're taking in a U32. We're going to return an I32. Instead of parsing here, since, do I put this here? So would it be as I32? Apparently, except now this is use of moved value my penny, value used here after move. Oh wait, so I moved my penny into here. My penny, get coin value. Well, it is returning. I guess I need to send a borrow to it. And then this is going to be the reference. Expected enum coin found reference. Did you mean coin? Oh, I need to put it here. And my penny expected coin found enum coin. Oh, right, because of that, so that's there. No need for parse. Parse is just for string to number. Okay, and then match match asterisk coin. Cannot move out of borrowed content and coin. You need to dereference the coin. They did mention that. Did we actually learn that in the book? I can't remember now. It's only been a couple days. Let's go back really quickly and take a look at if we've got, oh, that's So this is what we have in, this is all the chapters on Enum so far. Okay, well this is implement, oh, that's implements. Enum, option T. You know, I wonder, does it make more sense to implement that function? It might, I guess it might make sense. Oh yeah, they did show us that sum5 is equals option I8. Okay, I don't know if they've actually gotten us to dereference in the book yet. So let's go to good old Google. Dereference enum option T. Well, it's just the documentation for this. So pub enum. Is there a method to dereference? Conversion of 1 to, okay, so as mutable, so converts option mute T, okay. That's not exactly what I want. Oh yeah, they have the unwrap, I forgot about that. It was where you were suggesting I use that yesterday, and they say it's discouraged, but like it's good for my use cases. Then there's map to sort of like change things inside of it. Map might actually be good for like changing the money. Let's see. I'm not sure I'm gonna find it in here. You are already dereferencing with the asterisk operator. You're doing things correctly, but I'm also a bit stumped by why it didn't compile. Okay. So cannot move out of borrowed content. Borrowed coin. So let's go and do a full run so we can get the full compiler information. So cargo run. All right, so let total value equals add coin value. Consider using underscore total value instead. Oh no, that's just unused variable, never mind. Cannot move out of borrowed content. Here we go. So match asterisk coin cannot move out of borrowed content. Coin quarter state. Hint to prevent move, use reference state. So this state, oh, it's the quarter. It's the quarter, it's the state quarter. To prevent move, use ref state or ref mute state. Okay. So I want to come back to here and yeah, so I didn't notice the green right here. That's kind of like, I don't like the way that code handled that. Yeah, deconstruct is like assigning it to another variable, so you cannot dereference there. So I guess like if I do a reference to the state, then everything is happy. So I'm getting a reference to it, so I'm borrowing it essentially, right? So ref is different than using that. Expected enum US state, found reference. Oh, could I do that? Could I do state US state, except borrow it? Nope, not in this specific case. So I need to use that ref. In a few days, the Rust 1.26 compiler will be released. It'll include a patch where Rust will insert the ref automatically. Ooh, so okay, then I guess I won't worry too much about this. And then next week, when I'm when I'm continuing along, everything will work just fine. So ref is telling us that we're going to get a reference of this state. Now, what is... So this is getting a reference, like it's getting a reference to the point in memory. And this is something slightly different. I wonder, I hope the book is going to go over ref a bit. So that way I can understand this. I guess I'm not going to worry too much about it. Can I put in a inline here? Needing ref to get a... So it is a borrow that's in the context of destructuring. So so ref is a way to borrow within context of destructuring. And then this asterisk is destructuring coin. So destructuring coin. Okay. So it seems to be working here. Now total value is not used, but that's because we were in the middle of doing this. So if we repeated this entire line a couple times, and this time instead of my penny, then it would be shiny nickel, and then it would be the quarter, and total value every single time. Now I can print, and I'll say all my coins add up to cents. And now I can just put in total value. Save that. Standard option. Oh, I need to debug mode it. And okay, so that should get us what we want. Let's go in and try it out. So in here, cargo run. Oh, we never used the dime. That's fine. So my coin is worth 1 cent. My coin is worth 5 cents. I've got a Colorado coin, and that's worth 25 cents. Oh, interesting. So a side effect. So we have a side effect in there because of that match. It prints out Colorado twice. So it's not a good idea to put something in there because that is a side effect. We don't want to do that. Inside of a destructure, the compiler wants to know if you want to take ownership of the destructured value. Since the borrowed coin in the function declaration, we can't take ownership in the destruction. So we have to explicitly tell it, give me the borrow. And so if we can't do it, that's why I'll make that default later, so that way it just automatically happens. Since if we can't do it, why should we also have to tell them that? It kind of feels like a very Rust way. It's like, if we don't have a choice, don't allow us to make the mistake of not doing the choice right. Okay, so all my coins add up to some 31 cents, which is exactly correct. In a destructuring, ref equals ampersand ref mute equals, okay, So it's just, I can use ref in a destructuring. Can I use ref instead of the ampersand? It's a syntax thing. I hate it too. Can I use ref like just everywhere instead of the ampersand then? Like outside of destructuring, or is it only inside of destructuring? Also, my watch kept on trying to listen to that and give me Google search results. Only in destructuring. Okay. That is interesting. But it sounds like I won't have to worry about it in a couple of days. So I guess there's that. All right, so I have my sum 31 cents. You know what it sounds like to me? I can turn this into the proper number here. So if I just want to do this and pass instead of like get value, because I have coin value, but that only takes in a coin. Add coin value. What is the best way for me to like extract this? I guess, what was it? It was extract, right? I just saw it in here. It's unwrap. So I can unwrap this. And how does that get used? X.unwrap. Okay, so I can do total value dot unwrap. And I know this would crash if there was a none value inside of total value, but we don't have that right now. If you use rest nightly, you don't even have to worry about that right now. I'm not going to use rest nightly. As like learning, I don't want to also run into potential bugs that they may accidentally add in before it's been like brought out. So I'm happy using the stable version and just waiting until their release cycle comes, which seems to be fairly often anyways. So I'll wait for it. And if it's just in a couple days, I'm good. So I'm hoping that this gives me exactly what I want. Because now I can cargo run and I get all my coins add up to 31 cents. And I think the big thing is I have to be careful if for some reason total value had a none instead of a sum, then this would just be a hard crash and it would be over. But I'm controlling it and it doesn't have it in that time, so unwrap is cool. All right, so that gives me exactly what I sort of wanted to here. Awesome. Let's continue on with the book. Which means I need to go find where I was again. So we had match. Okay, matching with option T. We just went through this, the first example. Okay, matching sum T. Let's examine the first execution of +1. Okay, in more detail. When we call +1 and hand it the enum 5 or the option 5, would I say, do I say I hand it the enum 5 or do I hand it the option 5? Just sort of like curious about if I was like talking to another dev and I was saying what was going on, what word would I use for that? Just a curiosity. The variable x in a body of +1 will have the value of sum 5. Then we compare that against each match arm. So if it's none, we return none. So the sum value doesn't match the pattern none, so we continue to the next arm. Sum of I equal return sum of I plus 1. Does sum of 5 match sum of I? Well, yes, it does. We have the same variant. The I binds to the value contained in sum, so I takes the value of 5. The code in the match arm is then executed, so we add 1 to the value of I and create a new sum value with our total 6 inside. Matching none. Now let's consider the second call plus 1 in listing 6.5 where x is none. We enter the match and compare for the first arm. None and then none. It matches. There's no value to add to, so the program stops and returns the none value on the right side of the fat arrow. Because the first arm matched, no other arms are compared. I remember that from like when we were doing match as opposed to if statements. Combining match and enums is useful in many situations. You'll see this pattern a lot in Rust code. Match against an enum, bind a variable to the data inside, and then execute code based on it. It's a bit tricky at first, but once you get used to it, you'll wish you had it in all languages. It's consistently a user favorite. I feel like that might be one of the first times in a book that it's sort of like telling me, oh yeah, you'll love this, trust me. Matches are exhaustive. There's one other aspect of match we need to discuss. Consider this version of our +1 function. All right, so we have +1, we take in an x that is a type option I32, and it's going to return option I32, match x, sum. Okay, so it doesn't have the none. Well, if I remember correctly, the compiler basically tells you all arms, like all potential arms, must be in there. We didn't handle the none case, so this code will cause a bug. Luckily, it's a bug Rust knows how to catch. If we try to compile this code, we get this error. Right, because when I had like my own enum that I created myself, and I tried to, and I did a match on it, and I didn't put all the arms in because I wasn't using dime, it yelled at me, hey, you need to cover dime too. What if it does get used? Rust knows that we didn't cover every possible case, and even knows which pattern we forgot. Matches in Rust are exhaustive. We must exhaust every last possibility in order for the code to be valid, especially in the case of option type. When Rust prevents us from forgetting to explicitly handle the none case, it protects us from assuming that we have a value when we might have null, thus making the billion-dollar mistake discussed earlier. The underscore placeholder. Rust also has a pattern we can use in situations when we don't want to list all possible values. For example, an unsigned 8-bit integer can have valid values of 0 through 255. If we only care about the values 1, 3, 5, and 7, we don't want to have to list out 0, 2, 4, well, okay, yeah, all the way up to 255. Unfortunately, we don't have to. We can use the special pattern underscore instead. I remember we also used this in that one of the chapter 3 projects we did, and I can't remember which one. It's like, yeah, if we care about these, but we have a huge number of values, this is our catch-all. The underscore pattern will match any value. By putting it after our other arms, the underscore will match all the possible cases that aren't specified before it. The parentheses is just the unit value, so nothing will happen in the underscore case. As a result, we can say that we want to do nothing for all the possible values that we don't list before the underscore placeholder. However, the match expression can be a bit wordy in a situation in which we only care about one of the cases. For this situation, Rust provides if let. Match plus enums are cool because it replaces the visitor pattern. You can implement functions on either the enum or an enum variant. That's the cool thing. This is usually really hard and verbose in C++. And I think that's where, because I haven't had like any of that kind of pain in C++, I don't really see it in that way. But I can still see some value here. I just sort of, I guess I need to play around with it a little bit more and actually use it in a more realistic scenario. But I am also excited we're about to get to if let. All right, so where are we? We're in 6.2, 6.3, last section of this chapter. Concise control flow with if let. The if let syntax lets you combine if and let into a less verbose way to handle values that match one pattern and ignore the rest. Consider the program in listing 6.6 that matches on an option unsigned 8-bit integer value, but only wants to execute code if the value is 3. So we have some value, some, oh yeah, that's like setting it to be 3 and 8-bit integers. I think that's what it's doing, right? I vaguely remember them mentioning this in chapter 3. Match some U8 value. Some, if it's 3, we do this print line and we do absolutely nothing otherwise. We want to do something with the sum3 match, but do nothing with any other sum unsigned 8-bit integer value or the none value. To satisfy the match expression, we have to add underscore after processing just one variant, which is a lot of boilerplate code to add. Let x equals OU8 is basically a shorthand to say let x colon U8 equals 0. You can also do let x equals 0. Oh, interesting. Okay. All right. Well, I didn't realize that there was a shorthand for doing that as well. That is interesting. Okay. Instead, we could write this in a shorter way using if let. The following code behaves the same as the match in listing 6.6. If let sum3 equals some U8 value, print line 3. So if let sum3 equals, so if the thing is a 3, put it in here. If let takes a pattern and an expression by separated by an equal sign, it works the same way as a match, where the expression is given to the match and the pattern is its first arm. Using if let means you have less to type, less indentation, and less boilerplate code. However, we've lost the exhaustive checking that match enforces. Choosing between match and if let depends on what you're doing in your particular situation and if gaining conciseness is an appropriate trade-off for losing exhaustive checking. In other words, you can think of if let as a syntax sugar for a match that runs code when the value matches one pattern and then ignores all the other values. We can include an else with an if let. The block of code that goes with an else is the same as that block of code that would go with that underscore case in a match. Match expression that is equivalent to the if let and else. Recall the coin enum definition of listing 6.4, where the quarter variant also held a US state value. If we wanted to count all non-quarter coins we see while also announcing a state of the quarters, we could do that with a match expression like this. Okay, so let mute count. So we're setting up a count variable where we're going to get the number of them. Let match coin. So coin quarter state, print line state quarter from, okay. But if it's not a quarter, just increment the count. And if let, so we have our same count, if let coin quarter state. Okay, so type is the coin, it's the quarter, and specifically we take in, like, we're looking for a state equals coin, so we put that inside a coin, then we print the line, and then we have this else count plus equals 1. You know, ironically enough, I kind of feel that this is still a little bit easier to read But that might just be me. I'm not sure. Or maybe it's more of like if I use it a whole bunch, then I'll definitely love this more. If you have a situation in which your program has logic that is too verbose to express using a match, remember that if-let is in your Rust toolbox as well. Summary. We've now covered how to use enums to create custom types that can be one of a set of enumerated values. We've shown how the standard library's option T type helps you use the type system to prevent errors. When enum values have data inside them, you can use match or if-let to extract and use those values depending upon how many cases you need to handle. Your Rust programs can now express concepts in your domain using structs and enums. Creating custom types to use in your API ensures type safety. The compiler will make certain your functions only get values of the type each function expects. In order to provide a well-organized API to your users that is straightforward to use and only exposes exactly what your users will need, let's now turn to Rust modules. Ooh, like creating different files and like having like two Rust files working together. That is nice. But before then, we're going to where was it? Come down here and cat the README. So before then, we've reached the end of the chapter. We're going to rewrite the Fahrenheit to Celsius converter using enums. And I don't really like, I sort of like wasn't thinking too much. I ended up putting this into its own separate repo here. And then after I was like, you know, I should probably put everything into this one repo. So I'll just leave these for right now. I have the links to them. And let's go over to that. So Fahrenheit to Celsius. I'm going to create a new tab here. Mine Fahrenheit to Celsius. Okay, so I have my local temp convert. The thing that I want to do, if I take, if we sort of like go through this and like make sure that it works and sort of understand what it is. Temperature converter, what is the temperature you want to convert? So let's say it's like, I think it's like 51 degrees from the outside and raining. Is this temperature C or F? It's F. Your temperature is 10.555556 degrees Celsius. Okay, so that's working as it is, and we want to refactor this, not to sort of like add features or anything, but to use enums where we can recognize to use enums. So we only have 10 minutes, so we probably won't finish this. But I'm going to begin by creating a new branch. So git checkout -b. I'll call this using enums. And I'm going to open code here. All right, so temperature converter, here we go. So we're gonna want to sort of like get reacquainted with the code itself and think about where temperatures can be, like where we can use enums. So first thing I'm noticing, we do println temperature converter. Like that's not really anything to care about. We have input temperature is get temperature. Getting temperature returns this floating point number F32. So I suppose that what I can do is, oh, and the input symbol, we can set these as like you must be a character. By the way, Twitch chat is better than YouTube chat. So yeah, that's like going to be part of the decision making here. And just out of curiosity, those of you watching live now, or those of you who are watching this this VOD later on, can you put into chat or as a comment, do you prefer watching like a coding stream, a live stream on Twitch or YouTube? If I did switch back to Twitch, I would definitely be recording this onto my drive and then uploading them to YouTube. So I would still get a YouTube video out there. It just wouldn't be the live stream on YouTube. But I haven't made that decision fully yet. Okay, so we can just go overboard and make everything an enum. I don't actually know what the best practice is. You can directly export from Twitch to YouTube, no download needed. Yes, that's true. I've always been worried about quality. Like, does it fuzz things out so you can't read the screen very well? Does it like do anything? So that would just be nice to know. Like, I could experiment with all. I could just experiment and do another month on Twitch, and then make a real decision after that. Okay, so print your temperature is, let's see. So let's maybe just convert everything to options. So we do let moot input temperature, make the char and enum temperature Fahrenheit F32, Celsius F32. Okay, so we can, this char right here. So input symbol, when we get this should be an enum. So when we get temperature symbol, it's going to return the temperature. Let's put that up here and do enum temperature. And we're going to have, I'm trying to remember exactly how to do this. It's, I can have F, which is going to be a type, did I have that signed or unsigned? It's floating, so floating 32, and then there's it's not colon. Is it parentheses? It is parentheses, and then we have C, which is also an F32. Okay. You're yelling because we're not using you as an enum. No, you're thinking of structs making an enum, not a struct. Right, yeah. See, that's the fun part about like learning new languages, like getting the mental models correct and just sort of running into problems like these and then fixing them, and that sort of settles that mental model for me at least. Okay, so when I get this input symbol, and I could like go forward and even make the input oh no, this is a temperature. Okay, so, and then a simple, it should be symbol. I think it's yelling because the constructors aren't proper case. Well, this is yelling because I'm not using it right now. Make F32 into Fahrenheit 32 more descriptive. Oh, you're right. Yes. So if I do Fahrenheit, oh man, I'm trying to spell live on stream. Celsius, is it an S? I can't remember. It's not going to tell me if it's wrong or right. Yeah. So I like this. Is it normal to make, wait, variable Fahrenheit should have a camel case name? That's not camel case. That's Pascal case. I mean, am I wrong about saying that the first letter capital is Pascal case? I was sure that Camel case is first letter uncapitalized. Okay. Yes, thank you, Felix, and it yelled at me, so I changed it. Okay, so it's, oh, yep, Fahrenheit. Yeah, so interesting. Take a look at this. So if it's telling me that this should have a camel case, such as F Fahrenheit. I feel that like I could just change that to a Pascal case, and that's probably like a low value thing that like the developers are too busy working on other problems right now. And I'm actually curious if I run this right now in here, cargo run camel case. I wonder if that's something that I could just like pull request for them. Make it a little bit more descriptive and like proper. Okay, but I realized that just get into this, I've run out of time. It is camel case. In longer names, you do Fahrenheit converter thing struct, which is camel case. All right, I have to look this up because I could swear that was Pascal case. Pascal case. Pascal case is a subset of camel case where the first letter is capitalized. That is, user account is a camel case and user account is a Pascal case. The conventions of using these are different. You use camel case. Okay, so that, I mean, that's from Quora. Here, MSDN, Microsoft's one, Pascal case. The first letter identifier and the first letter of each subsequent concatenated word are capitalized. You can use Pascal case for identifiers of 3 or more characters, like that. Camel case, the first letter of identifier is lowercase and the first letter of each subsequent concatenated word is capitalized. So this is the definition that I was always taught. So from this, so it is both Pascal case and camel case according to Google. This is really important stuff. Yeah, I kind of want to go and see if I can do like a pull request to that and say like, and maybe an issue. Say like, I believe that that's actually Pascal case according to the definitions that I've been taught in all of my computer classes that I've taken over the years. But I also don't want to piss off the community. So I don't know. What do you think? Should I leave a comment? Should I follow this up and actually try to get that changed in that message to Pascal case, or should I just leave it be? Let me know the important things that we're doing here on this stream. And I will make sure that I push up these changes. I know I'm gonna put in a comment right now, which is in, I guess maybe not comment. I am going to in here, in my message for here, which is sort of beginning to refactor to use enums and options. We'll hit that, and I'm going to publish that branch. So to get to this code, we can come from the other one. My Learning Rust branch or repo, which I have linked in the description to the stream and the VOD, that has a link to where this code is living, which is the Learning Rust. And in the README of Learning Rust, I can just go, oh, not in here. I can go here, and I have a link to the convert temperatures between Fahrenheit and Celsius, and that's where we can find the code that we sort of looked on here. So it's both, yeah. So let's push up this code as well. So I'm going to say finished chapter 6. And we'll push that up. And finally, in here, we'll vim readme. Good luck building the Rust compiler. It takes 45 minutes to bootstrap. Don't attempt this on a laptop, but yeah, it would be a valid issue, I think. Yeah, and this is a notebook that I'm using. I mean, it's a powerful notebook, but it's still a notebook. Okay. I will think about, I might just create an issue on it. I assume that they have their, because Rust is an open source language, I think, right? Yeah, it's Mozilla making it. They do everything in open source. I will consider creating an issue, and if I do, I'll talk about it on the stream that I created on. Maybe I'll create it live on one of the streams. Okay, so here, what did I do? I opened up code. Oh no, this is my, okay. I'm getting confused by all the windows that I have open. All right, so learning Rust. In chapter 3, we're doing that. We're currently at, and I'm gonna yank that, put this down here. I'm gonna say finished chapter 6. And now we are converting refactoring the C to F project to use enums. Check the using enums branch. All right, so save and close that and get status. And updated readme with the current plan. Get push. All right, so that's pushed up. Everything is up on GitHub, so now you can all go and take a look at that. It is after 8 a.m., so it's time for me to get ready for the day. And I hope that you guys are either going to have a great rest of your day or a great end of your day, depending upon where you're at. Geez, I can't even put links in the chat. FSF's YouTube chat, I said, oh, I'm sorry. I have not done any. I just went into the settings and I can't, there's no like allow anything. Can I click on your name? No, I can't even click on your name and make you like a mod so that you can do that. All right, so that is like really, it's really good things to like sort of think about where I'm gonna go. All right, well, I hope that everybody has a great Thursday. If you enjoy this stream and you're not following this channel, please follow the channel so that way you can see future streams and videos. Also, I have a link to my Twitter account. I tweet out when I'm going live. We usually write about that, when I go live because, it's 7 a.m. And if I end up making any kind of switch over to Twitch or anything else, I will be posting all the links for those on Twitter. So if you don't want to miss those, please follow me on Twitter. And I have linked that in the description. Okay, and I want to copy yours off in case I lose the chat. So thank you, Felix. I'm just going to put you somewhere. And again, Have a great day, and I'll see you guys next time.